Welcome to Soil Doctor, where we believe that understanding your soil is the first step to gardening success. Today, we're addressing one of the most common challenges gardeners face: dry, uncooperative soil that seems to resist all your best efforts. With the right knowledge and techniques, you can transform problematic dry soil into a fertile growing medium that supports abundant plant life. At Soil Doctor, we approach soil health from a scientific perspective. Dry soil problems often stem from disruptions in what we call the soil-water relationship. This relationship is governed by soil particle size, organic matter content, microbial activity, and the formation of soil aggregates. When soil becomes severely dehydrated, the organic compounds that normally help soil particles bind together can develop hydrophobic properties. These compounds essentially create water-repellent coatings around soil particles. The technical term for this is hydrophobicity, and it's particularly common in soils with high fungal activity that have dried out completely. The soil water potential, the energy required for plants to extract water from soil, becomes drastically increased in dry soil conditions. This means plants must expend more energy to access limited moisture, creating stress even when some moisture might be present. Understanding this principle helps explain why simply adding water to dry soil often fails to solve the problem immediately. Professional soil assessment goes beyond visual inspection. At Soil Doctor, we recommend the following techniques. The infiltration test provides quantitative data about your soil's ability to absorb water. Place a 6-inch diameter cylinder like a coffee can with both ends removed on cleared soil, press it about 1 inch into the ground, and pour 1 inch of water inside. Time how long it takes to absorb completely. Healthy soil should absorb water at a rate of 1 to 2 inches per hour. Significantly slower or faster indicates problems. Soil coring allows you to examine soil strata and moisture distribution. Use a soil core sampler or dig narrow, foot-deep holes in different garden zones to extract vertical soil samples. Examine these for color changes, moisture boundaries, and root penetration patterns. This reveals how water moves through your specific soil profile and where problems might be occurring. Aggregate stability testing helps determine soil structure quality. Take a sample of dry soil and place it in a jar of water. Healthy soil with good structure will maintain some aggregate formation rather than immediately dispersing into individual particles. Poor aggregate stability indicates weak soil structure that cannot maintain proper water channels. The Soil Doctor approach emphasizes biological solutions to physical problems. Enhancing soil biology creates self-improving systems. Fungal-dominant composts specifically benefit dry soil conditions, while bacterial-dominant composts, like those made primarily from green materials, work well for vegetable gardens. Fungal-dominant composts, containing more woody materials and leaves, create more stable soil structures that resist drying. For dry soil rehabilitation, aim for compost that has aged at least 1 year and contains significant amounts of decomposed woody material. Actively aerated compost tea serves as both hydration and inoculation for struggling soil. This living solution introduces beneficial microorganisms while addressing hydrophobicity. Create it by brewing mature compost in actively aerated water with microbial food sources for 24 to 48 hours, then apply directly to soil as a drench. The microbes help break down hydrophobic compounds while establishing beneficial colonies that improve soil structure. Humic and fulvic acids are powerful amendments for dry soil conditions. These organic compounds, derived from highly decomposed organic matter, improve soil's cation exchange capacity, its ability to hold nutrients, stimulate microbial activity, and help form stable soil aggregates that improve both water infiltration and retention. Apply them as liquid concentrates or in granular form mixed into compost applications. At Soil Doctor, we view plants as active partners in soil improvement. Deep-rooted pioneer species can be strategically planted to break through compacted layers and begin the soil healing process. Consider comfrey, which sends roots down 8 to 10 feet while accumulating nutrients that later benefit the soil when leaves are cut and used as mulch. At Soil Doctor, we view plants as active partners in soil improvement. Deep-rooted pioneer species can be strategically planted to break through compacted layers and begin the soil healing process. Consider comfrey, which sends roots down 8 to 10 feet while accumulating nutrients that later benefit the soil when leaves are cut and used as mulch. Alfalfa performs similarly, with roots that can penetrate 15 feet deep while fixing nitrogen. Phytoremediation employs specific plants to address soil issues. For dry, depleted soils, sunflowers help break compaction while building organic matter. Mustard family plants produce compounds that stimulate microbial activity when turned into the soil. These soil conditioning crops can be planted for just 30 to 60 days before your main crops as a preparatory treatment. Native plant integration provides long-term soil stability. Research shows that native plant communities develop symbiotic relationships with local soil microbiomes, creating resilient systems that maintain moisture balance despite weather fluctuations. Incorporating even a few native species into your garden areas can establish beneficial microbial networks that extend throughout your soil. Water management requires precision and strategy. Soil moisture sensors provide objective data about moisture levels at different depths. This technology, now available to home gardeners, eliminates guesswork and prevents both under- and overwatering. The most useful sensors measure moisture at multiple depths simultaneously, showing whether water is actually reaching deep root zones. Water management requires precision and strategy. Soil moisture sensors provide objective data about moisture levels at different depths. This technology, now available to home gardeners, eliminates guesswork and prevents both under- and overwatering. The most useful sensors measure moisture at multiple depths simultaneously, showing whether water is actually reaching deep root zones. Hydrogels, when used judiciously, can provide targeted moisture support during the rehabilitation phase. These polyacrylamide polymers absorb hundreds of times their weight in water, releasing it slowly as soil dries. While we don't recommend widespread application, strategic placement in planting holes can support new plants, while broader soil improvements take effect. Hydraulic redistribution leverages plants' natural abilities to move water through soil. Some plants with deep root systems actually pump water from deeper, moister soil layers to drier upper layers at night. By including these hydraulic lift plants in your garden design, you create natural irrigation systems that help maintain moisture balance throughout soil profiles. Thank you for consulting Soil Doctor for your garden health needs. Remember that soil improvement is an ongoing relationship, not a one-time fix. By approaching your garden as a living ecosystem and implementing these professional strategies, you'll develop soil that grows more resilient and productive each season. Subscribe to our channel for more in-depth soil science for home gardeners, and share this video with fellow soil enthusiasts. Together, we can build healthier soil for a more abundant future.